Hello, my name is Chris Esselman. I am a graduate student in Art Edison's lab here at the University of Georgia, and I'm really excited to show you all our HPLC system that we use every day in the lab. So let me walk you through some of the modules that we use. So the first module I want to show is our quad pump. In our quad pump, we have the ability to use 4 different solvents at the same time. And you can see this by A, B, C, D, each connected to different solvents. And we can change the percentage of solvent going through our system using the software that I'll show later in the video. Also in the quad pump module, we have our purge valve. The purge valve, we can twist this knob to the side to let solvent go through to the column and the rest of the system, or to go directly to waste. And so we'll use this often for maintenance of the system or to change solvents and stuff like that. Put this back on. And now let me show you the next module, which is our auto sampler. Our auto sampler lets us automatically inject complex mixtures into our HPLC system. We can inject in a sequence, or we can just inject one at a time. And we also have a wash bottle in the back there so that we can wash between injections of mixtures. Our next module I want to show is our UV detector. So we have the ability to detect UV and also other visible light spectra here. And I'll show later, we use this, but we also use a different module, our mass spec, more often. So I'll show you that later. Okay, the next thing I'd like to show is our splitter. So the splitter really helps us so we can split what goes to the mass spec, what goes to our fraction collector, or what goes to waste. So when we get a run going, you'll hear the splitter. That's usually the loudest thing that you hear. Our next module is our fraction collector, and this is really the power that we use this HPLC for our fraction collecting. So in our fraction collector, we have the ability to collect up to 140 different fractions, seen here. And we can set it up so that it goes in a snake-like motion, so we're not, missing anything during our run. We also have different inputs that we can put into here, seen here, where we can put different larger fraction volumes. So if we want to, if we're not necessarily going for 140, we can also use larger fractions. This is our column compartment. We don't have a column in here now. We just have a piece of metal pipe to let solvent go through. But you can put different columns in here and heat them at different temperatures depending on the gradient that you're using.
Okay, I'm going to take a quick pause in the video here because I want to mention more about the columns that we use in the lab. We mainly use Hillock columns and C18 columns. Our Hillock columns we use to separate more polar metabolites. So this would be an extraction that we use a more aqueous solvent, like a mixture of methanol and water. And I'm going to make sure to put a link in the description below to the columns that we use. But for example, for more preparative HPLC, we use a column like this. This is an X-bridge BEH amide that is 10 millimeters by 250 millimeters. We also use a smaller column here when we are finalizing our gradient, and this is an X-bridge Hillock that is 4.6 times 150 millimeters long. The other type of column that we use is a C18 column, and this is where we use to separate more nonpolar metabolites. I've been messing around with doing extraction, which is a Bly-Dyer extraction or a Maytash method extraction. 2 columns that we use here. This column, you can notice that it has a pre-column on it because lipids are bigger molecules that could gunk up the column. So we have this pre-column to protect against it. And this is an A6L 5 C18 AR, which is 4.6 millimeters times 150 millimeters. And I've also used this column here, another C18, which is a Prontosil Eurobond C18. Which is 4 millimeters times 125 millimeters. Again, I'm going to put the description of these below. Quick pause is over. Back to the video.
Lastly, we have our makeup pump. This is just to make sure that we have enough pressure going to everything in the system here. Okay. Lastly, we're really excited about for this system is our mass spec that we use. And so we can do mass detection, so we're making sure we're not missing anything that's coming off of the HPLC. So I just showed you all visually each one of our modules on our HPLC. Now I want to show you guys each one of the modules on the software here. So as you can see on the software, it is set up module to module. So we have our auto sampler, our quat pump, the column compartment, the flow modulator, which is just our splitter from the mass spec to the fraction collector or to the waste, our UV detector, the mass spec, where we collect our fractions, and also the makeup pump. So in this software, this Agilent software, you can load different methods that are pre-saved. So we have a bunch of different methods here. So I already have one loaded up, which is just our wash method. So I can show you I'll show you all how to manipulate it. So you can click on each individual module and change the method there. If you want to just like say test something and change a specific module, but I like to change the method in its entirety. So I go to method and edit entire method, and I click through just these kind of default pop-ups that get here, just saying OK. All right, and you get to this screen. As you can see below, you have a visual of our gradient, and each one of the modules are these tabs here at the top. Okay, so let me walk you through each one of these tabs. So you can change the amount of volume that you're going to inject into the system. You can change where the needle will be washed, and we usually wash with 100% methanol for our wash needle. You can change how quickly and how fastly the needle picks up your mixture and injects it into the system. And you can also adjust where that needle, how far it goes down into your bottle to get your system. Because sometimes, especially when you have really, really dense, concentrated, complex mixtures, you might have a few things that fall out of solution, and you don't want to inject anything that's not dissolved into your system. The next tab for the module I like to change is the quat pump. And so this is really the main heart of where you're adjusting your gradient here. So you can change what solvent that you're putting into the system, and this will depend. You have to manually change the bottles for which solvent. You can change how quickly the flow is going, the pressure limits, the stop time, and post time for cleaning. And then here you can change the gradient, actually, the percentage of which solvent goes in and how quickly and what time these percentages change. ISO pump 2 is again just the backup pump, and this will just depend on how quickly that your flow is going through the system. The column compartment, you can adjust the temperature of your column here, and that's mainly what we use it for. The flow modulator, so this is an important part of our workflow here. So when we're just testing out a gradient on a new complex mixture, most of the time we will want splitting enabled, and we want it to be split between the mass spec and the waste. So we don't want to collect fractions when we're just testing out our gradient and we're not sure if we actually want them for future work. So when we do want to collect our fractions though, we will have this enabled, and we'll have it going to either the mass spec and the fraction collector, or we don't even need to have the mass spec on each injection. We could have it go to waste and also the fraction collector as well. We wouldn't want it to waste actually when we're collecting our fraction. We just want to go right to the fraction collector. Okay. Lastly, the DAD, we have the UV vis, and we can change the wavelength here to if we're using UV instead of the mass spec, but most of the time in our workflow we're using the mass spec. And the fraction collector here, we can change when and where we're collecting our fractions. And as Art has talked about in his talks, we usually collect on time, but you can also collect based on a certain peak or a specific mass that you're interested in collecting. So after that looks good, we don't really change this screen. This is just the drying gas, so the nitrogen going through the mass spec. But this screen we do change. So there's two different modes that we can have the mass spec. We can have the mass spec in scan mode, and that's usually the mode that we do when we're collecting our fractions. It's basically, it wants to detect every mass that's coming in between a mass to charge ratio of 130 and 1250 for this case. And we will turn this down to 10 when we're actually collecting our fractions. We have it higher here so that when we're just testing, we can get rid of some of the noise to really see where most of the metabolites are coming out. We also have a different mode called SIM mode, and this is where we can do our mass-based detection. So say we're doing more targeted metabolomics, we can find a specific fraction that has a metabolite that we're interested in. Okay. So once you have all of these and you're ready to go, you can click this button here to loading a single sample. You can input your injection volume, sample name, where you want to save this data, and hit run method, and it will continue to run. And next I will show you all the method after running. I'll show the needle going in and injecting into the system, and also what the fraction collection looks like. Alrighty, so I'm going to show you all injecting a sample into the magnet. So it is looking over, like a big claw machine, over the sample that we want to inject, and that's that one in the front there. It is going to pick it up, and then the needle is going to go down into the sample, however low we said to go, and it's going to pull up the amount of volume that we want it to pick up. Ready? Set it back down, and now the next step is that it will wash the outside of the needle with the wash solvent that we told it. So that's where it's going, to position 40, where it's picking up the wash solvent, and this is just complete methanol. It washes the outside. And inject it into the system. So as you can see, as the sample comes off the column, it goes to the fraction collector, and it is dripping into each of the different fractions. And I just have 5 set up here, but you can imagine that we can get 140 of these. Hello again. So I just showed you all how to set up the HPLC. And I also showed what it looks like when solvent is coming off of the column. So now I'm going to show you how to get a first look at the data after your HPLC run is finished. So if we look here, this is the screen that I showed previously on how to set up the HPLC. It's a little different. You can notice it's all grayed out from offline. This is because I'm using a slightly different version of the software that's not directly hooked up to the instrument, so that we can do data analysis without having to worry about affecting anything online with the instrument. But it's the same exact software, but just not directly connected. So if we go to the data analysis tab, we can take a look at our data. So nothing is loaded here, but you have different data directories on this left side. So I'm going to go into a sample that I ran previously this year to show you how to analyze it. So I'm going to double click on single runs, and let's take a look at what it looks like. So this is a screen that you first look at, and I'm going to show for this demonstration just the mass spec total ion chromatogram, or total ion count. So I'm going to just select the MSD1, and again this is scanning, so this is looking for metabolites that are between 10 and around 1250 mass to charge ratio. We're not doing a SIM scan, which is just looking for a specific metabolite. So this is kind of like adding up all of the metabolites for a given time point, and that's how you get this tick chromatogram. Okay, so if I click on MSD1, we have this big kind of mess, so let me show you how to clean this up. I'm going to first go to signal. All right, and we have all these black spots which are part of the integration, so I'm going to go back to integration, and I'm going to just make a really high height reject to get rid of these kind of black spots here. Enter. Okay, and now we have a nice looking chromatogram. Nice. If we go to purify, the purple stripes you're showing are actually each individual fraction. So the purple stripes, we have 140 different fractions that we collected with this particular sample. A really cool thing that you can do is if you go to the spectrum tab and you click on average a selected set of spectra. So I'm gonna click on this, and I'm just gonna pick a peak and go like that over it. And sometimes it hides at the bottom for this software, so I'm gonna lift it up. Let's let it load. So this is the actual mass spectrum that makes up, that is underlying that peak that we just selected. So we can look here, and maybe something that's around 235 mass to charge ratio is a big metabolite that's mainly making up that peak. And you go in there and individually check that out, and I'm using some scripts that I'm writing to try to use this to validate what we're seeing in the NMR spectrum. So lastly, after you get this, you can make nice figures by going to this report, and we can print a report or specify a report and get it nice and formatted the way that you like. Thanks so much for watching this video about how we use our HPLC in the Edison lab here at the University of Georgia. Please reach out if you have any more questions about the HPLC or any other cool stuff we do here in the lab, like our NMR spectrometers or any other stuff. See ya.